Okay, so for the logarithms, there's these three rules that we're going to follow. Now, in all of these, all right, they have this m and this n represent two positive numbers, all right? So they're just representing numbers. Now, we have three rules that are going to be weird to you, okay? And I'm basically going to do examples so you can see how they work instead of me talking about them. But if you have something like this, two numbers multiplied, you can actually expand this by running it like this. All right, if you divide, then you subtract. And if you have this as a power, you can actually multiply it by bringing this to the front. Does that sound familiar when I say that? When you multiply, you add. When I divide, you subtract. When I have a power, I can multiply. Does that sound familiar to you? It should sound like the exponent rules, right? They're just kind of backwards. So I'm going to write it like this. I'm going to tell you that when you're expanding, which is basically what you're going to do part of the time, when you're expanding, you got to follow those rules in order like this. Right? So you have to go in order from the top to the bottom. But if you're going to condense, then you're going to start with this rule and you're going to go up. All right, so condense means that you have several logarithm functions, so you're going to bring them all together. All right, and expanding, you have one logarithm, you want to expand that into at least more than two logarithms, two or more. All right, so here's an example. If you have this, you have to first look at it and see how many terms do I have. I have 5 times a times b. All right, I have 3 terms. Now that I know that they're being multiplied, I can actually use the rules of logarithms and say this would be log base 10 of 5 plus log base 10 of a plus log base 10 of b. Okay, that's it. That's all you do. All right, so again, if you're multiplying here, notice that I'm multiplying these. I can actually expand them by adding them like that. Okay. Now on number 2, same thing. Notice that on this one, I have a times x cubed. So I have 2 terms right here. So I can start off by expanding it like this. Log base 5 of 8 plus log base 5 of x cubed. Are you with me so far? Okay, so now the next part is you have to then look at it again, and if you look at this part right here, I can actually go back to rule number 3. You see how I drew an arrow here? So this 3 can actually come to the front of this logarithm. All right, so this would be log base 5 of 8 plus 3 log base 5 of x. And that's it. So that would be your answer. That's as far as you can expand. Okay? So that's how those two work. Now, this last one, it looks a little difficult. So you have to, again, follow the rules from the top to the bottom. All right? So rule number 2, or law number 2, says that if you divide, you can actually subtract. So that's the one I'm doing first. So I have log base 10 of a to the 5th minus log base 10 of the square root of b cubed. Are you with me? Okay, so again, I'm using law number 3. Okay, so now, if that's what I have, then I'm going to go to rule number 3, and I'm going to write this 5 in front of this logarithm. So I have 5 log base 10 of a. Now, before I go on, remember that there's a way for me to write this square root as an exponent. So this square root, I can actually write it like this. Right? So the 1/2 power, right? If I raise something to the 1/2 power, that's the same thing as taking the square root of it. Okay, so now this is going to be 5 log base 10 of a minus log base 10. By the way, how can I combine those? If you have a power to a power, you multiply, correct? So this would be b to the power of 3 over 2. Now this is the exponent. Now I can bring it to the front. All right, so I can go ahead and bring this 3/2 to the front of this logarithm. So this is going to be 5 log base 10 of a. That hasn't changed. And this one is going to be 3/2 log base 10 of b. Kind of weird. All right, so again, this is going to take a little bit of getting used to, right? So don't slack on this, because this is going to cost you on the back end. The more you wait to try to do this, the harder it gets. All right, so let's go to the back again. We're just expanding. So in example number 4, one more time, I'm expanding, right? So notice that I have 6 squared, x squared, y cubed. Those are being multiplied. So I can write all of those like this. Okay, so that's always the first step. Always try to break them apart by using law number 1, which says that if you have something multiplied here, you can write it like that by adding those logarithms together. And then go to rule number 3 after that, which says that if you have a power here, I can actually bring that power to the front of each one of these logs. All right, so this is going to be 2 log base 2 of 6 plus 2 log base 2 of x plus 3 log base 2, log base 2 of y.
So you just go through all of the steps?
Yeah, if you can. Sometimes you can't, right? Like the first example that I showed you, you can only do one step, but you should at least try to be looking for it. All right, so yeah, that's what you're doing. Yeah, and you always start with it's either the first step is always going to be the multiplication, which is rule number 1, or the division, which is rule number 2. It's either or. Does that make sense for the most part? Not all the time, but it's either or, at least in this worksheet. So now we're actually going to go backwards, and the reason I drew those arrows, right? The reason I drew those arrows on your rules, if I turn this around, notice that I put if you're expanding, you're going to start here, right, on this rule or that rule, and then go to that rule. But if you're condensing, then you're going to start with this, and you're going to go up. So you always start with this rule. Now the weird part is that you're going to go from right to left now. So normally they're going to look like this. I can bring this k up as a power. So that's the first thing that's going to happen when you're condensing. All right, so let me show you an example so hopefully it'll make more sense. So I have to start off with this problem. All right, so if I have this right here, I have to bring this 3 up as an exponent. So this would be log base 5 of 7 plus log base 5 of x to the 3rd. Okay, so now that 3 became the exponent. And then now I'm going backwards. Now I started with rule number 3. I'm going to go up, and if I'm adding 2 logarithms of the same base, I can actually combine those by multiplying the inside of those 2 logarithms. Are you with me? Kind of weird. Right, again, I know this is completely foreign to you because you probably have never worked with this very much, if at all. Has anybody ever seen this before? Maybe you? Okay. I know that you use logarithms sometimes in chemistry, I was told, but I haven't. I don't know what the extent of what you're doing on that is. So anyway, on this one right here, before I begin, so I'm not doing any rules of logarithms at this point. I'm going to write this like this because that's going to be easier for me. Remember that if I divide something by 2, that's the same thing as multiplying times a half, right? So that's where I'm going to start off. Now, again, I have not done any of the rules of logarithms. So now I'm going to use those laws. I'm going to bring that 3 up as a power. I'm going to bring this 1/2 up as a power. All right, so this would be log base 6 of m cubed minus log base 6 of n to the 1/2. And again, please note that those rules only work. Those rules are only going to work if these 2 logarithms are the same. By that I mean base 6, this is base 6. Does that make sense? So now that I have that, remember, if I subtract, then I can actually divide those 2. So this would be log base 6 of m cubed over n to the 1/2 power, which, if you had a multiple choice, which this is what your quiz is going to be like, it's actually going to be matching, okay, on Friday. You can rewrite this as log base 6 m cubed, and remember, n to the 1/2 power is the same thing as the square root of n. All right, so either or would be correct. Okay, on problem 7 and 8, you're going to do the parentheses, what's inside the parentheses first before you go on and do anything else, all right? So don't try to combine those 2 right now. Like, you got to do that part first. So I'm going to bring this 3 up. So I have log base 2 of x cubed minus, now remember I'm adding I'm adding here, right? I'm adding two logarithms of the same base. And if I have that, I can actually multiply 4 and x. This would be log. So this, I'm writing this in parentheses just to let you know that this right here was the same thing as this.
So you don't always start there.
Yeah, the parentheses kind of tell you, hey, do this first before you combine. All right, so that's the whole reason of the parentheses. Okay? And then now, I am going to divide. Like that. Right, if I subtract, I divide. And if you wanted to simplify a little bit further, this would be x squared over 4. But if you got that, I mean, I would count that right. I mean, it's fine. And maybe that would be even more correct because I don't want to necessarily eliminate that x. But anyway. All right, number 8. Okay, again, make sure you do whatever's inside the parentheses first. Okay, so don't bring that 2 up as a power or anything yet until you deal with that. What do you do when you subtract? You divide, right? So this is going to be, what's 32 divided by 8? Hopefully, somebody said 4, hopefully. Alright, so this is that. So I'm going to write it like that so you can see all my steps. Alright, so this 1/3 is going to go up as a power. So this is going to be log base 3 of 1 over 64. And all of this is going to be to the 1/3 power like that. Now, do you remember what to the 1/3 power is equivalent to? Like if I say raise this to the 1/3 power, that's the same thing as a cube root. Don't forget. So this is really the cube root of this number, whatever that is. Okay. So anyway, before I go on, this is 2 log base 3 of, this is 4, plus log base 3 of 1 to the 1/3 power, 64 to the 1/3 power. So again, notice the rules, still using those rules, right? I'm going to bring this up as a power now, so I have log base 3 of 4 squared. And by the way, if you're looking at this last one, you're like, oh my god, this is bad. It is bad, alright, but this would be like the hardest one you're going to face. Okay, so you're not going to have like 10 of these or anything like that. You may have like one of those, and that's it. Okay. And this will be log base 3. Now 1 to the 1/3 is the same thing as the cube root of 1, which is just 1. Alright, so this is going to be 1. And now 64 to the 1/3 power is the same thing as the cube root of 64. You know what the cube root of 64 is? Lower. Yeah. So this is 4. And then after all of that, finally, now that I have one logarithm with nothing in front of it, or that's the key, you don't have any, you must not have anything in front of it. It's kind of hard to say that. So you have nothing here, nothing here. Now you can combine these by multiplying them. By the way, what is 4 squared? 16, right? So this is 16 times 1/4. So make sure you get to that step where you have nothing in front of those logarithms before you combine those into with that multiplication. Now 16 times 1/4 would be the same thing as 16 divided by 4. So this is log base 3, 4. Okay, now before, I noticed that there's some problems on the back of the homework that are not on the notes, so let me just quickly show you how to do these, because that's going to be the easiest part for you. Somebody wake up Caden over there, and over there, you look asleep over there. Get your head up. Okay. Now, Caden, you asked me, right, how do I plug this in the calculator? So I'm about to show you how to plug this in. Now, on the homework, the last, the last 8 problems on here, they're going to be fast because you're going to be able to use the calculator. All right, so let me show you. On the calculator, and notice, by the way, then this is use the calculator because it's going to be pretty hard for you to know 2 to the what power is 9. I don't know. Okay, I know maybe it's got to be between 3 and 4, right? But I don't know anything else. You see that? So what you do to do that is you're going to go to the button Math, which is right here, so go to math, press enter. Now you can scroll down if you want to, all right, but listen to me. You can scroll down if you want to, but if you scroll up, if you press the directional button up, it actually takes you to the bottom of the menu. So if you press up, the option A right there, that's log base, and if you press enter, well, the rest is kind of self-explanatory at that point. You just plug in whatever they gave you here. All right, so that right there would be 3.170. I'm rounding to the third decimal place. So let's just round to 3 decimal places. All right, so again, one more time. All right, if you missed it the first time, go to math, scroll up, go to log base, press enter, and then just type in what you have. 6.843. Okay? 6.843. Does that make sense how to put it in the calculator? Now obviously I couldn't show you that before the quiz because then you could have done the whole quiz without it. Okay? Siri, you don't know anything. Okay. So any questions about this?
Do we have to round?
Third decimal place, please. Okay, so remember, just look at the third number here, and then just look at the one next to it. And then if it's over 5 or over right, you go up. If it's 5 or, under 5, then you leave it alone. Okay, so now you know how to do it. Okay, well, that's it, guys. If you got any questions, please let me know. Quiz will be on Friday. So this is not due till Friday. I know you got plenty of time, but trust me, it gets more difficult than this. So please try to make as much progress as you can on this one.